Alright, next problem, example, I should say. A bar bent and loaded as shown in the figure. Determine the moment of the force F about O. Alright, that's it. So we are to solve for the moment of this force about this point O. Okay, so anong kailangan natin para ma-solve yung moment? So very simple. The moment of the force about O is just equal to the cross product of R. Okay, the position vector from point O to the line of action, to any point along the line of action of F. So we need two things, ano? Oh no, I think, yeah, blurred siya yung video. Alright. So we need R and we need F. Expressed natin in Cartesian vector form. So maybe we can, first maybe we can, we can identify the coordinates of each point. Yung head ng force natin, medyo mali yung figure, but if you have you can just refer to your module if you have a difficulty. And medyo mali kasi yung pag-print ko ng figure. I should have made it larger, bigger, para visible yung mga dimensions. Anyway, yun na. So, kailangan mo yung mga coordinates ng mga points natin, important points. Yung head ng ating force, ano yung coordinates ng head ng force natin. X coordinate is, ano yung X coordinate? I-convert na lang natin sa meters, no? Naka-millimeters kasi yung given, but you may or may not convert it to meters. Well, I prefer kasi meters na lang. So we have X coordinate ng head ng force natin is we have 200 yun, ano? Yung X plus, may additional siya na 75, that's 275, or is 0.275 meters. And then yung Y coordinate naman natin, so Y coordinate, Y, that's 250 plus 250 plus 150, that is 400. I don't know, 0.4 I should say. Z coordinate naman is 150 plus 140. That's 290 mm, or this is 0.29 meters. So coordinates ng head ng force, and then yung tail ng force naman, coordinates niya ay yung tail ng force natin, X is 0.2, Y is 0.25, Z is 150 or 0.50. Okay. What else? Of course, yung origin natin is 0, 0, 0. 0, 0, 0. Yung coordinates, yun lang ating importante. So, let us, anong unahin natin? Yung R muna. R here, the position vector. So, ano yung position vector na yan? That's from point O where we are taking moments about. Okay? Point O to the line of action of the force. So, ito yung line of action. You can extend actually yung line of action niya. But, kailangan natin yung second point, of course, dapat known yung ating coordinates at the second point. Okay? So obviously, ito na lang yung ating pipiliin na linya or line. Since at that point, at those 2 points, alam natin yung coordinates so that we can solve for the position vector. So, ito yung pipiliin natin. So, ROA. So, position vector natin, ROA. Alright, so head minus tail. 0.2 minus 0, so 0.2i 0.25 minus 0 plus 0.25j plus 0.15 minus 0, that's 0.15. Okay, so ito na yung position vector ng ito. Okay, line natin. And then next is the Cartesian vector form of f. Cartesian vector form of f. So express f in Cartesian vector form. Given naman yung magnitude ng f natin, that is 875 newtons times ito, head minus tail. Yung unit vector natin, head minus tail ulit tayo. So unit vector is equal to position vector over yung distance between those 2 points. Now, I hope you can still remember. So position vector, yung numerator natin 0.275 minus 0.2. So we're left with 0.075 now. 0.075i plus we have 0.4 minus 0.25, that is 0.15 j plus 0.29 minus 0.15, that is 0.14 k. Alright. Yun yung distance natin. Sana naalala nyo pa? Siyempre, dapat lang maalala. Okay, so yan na yung pag-compute natin ng pag-convert natin ng f into its Cartesian vector form. So the resulting value would be, we have 300.398. You will get the same naman if you use millimeters dito. Okay lang. You will get the same value for f in Cartesian vector form. Okay, so kompleto na yung ating kailangan para ma-solve natin yung moment ng force about O. We have the position vector, ROA in this case. And then yung F in Cartesian vector form. So ito na yung Cartesian vector form ng F natin. Alright, now mag-cross product na tayo. So MO is equal to the determinant of, so unahin natin yung ROA, we have 0 point. Yung coefficients lang ilagay natin. Ayan. Ito, we have, and then this is ROA, coefficients ng ROA. Okay. Next is yung coefficients naman ng F sa Cartesian vector form. So we have the magnitudes, no? Then the directions. Okay, so para ma-solve yung determinant, again, using basket method, kukopyahin natin yung first two columns. Ayan, okay? Then basket, drawing tayo ng basket. Okay. So multiply natin yung mga diagonal na downwards. Okay, so we have 0.2 times 600.795 K plus 0.25 times 560.742 I plus 0.15 sorry, times 300.398 J minus, drawing ulit tayo ng lines, diagonal lines, ganyan, gano'n. Okay. So, multiply ulit natin. So, we have 0.15 times 600.795 I plus 0.2 times 560.742 J plus 0.25 times 300.398 K. Okay? So, simplify lang natin. Okay, so simplify. We're left with 120.159 K. Ito yan. Plus ito 140.186 I. Ito plus 0.15 ay sorry. Sorry. Mali. Plus 45.6060 J. Ito naman, distribute na yung negative. So, subtractive na lahat yan, no? So, minus ito 90.119 I minus 112.148 J. I don't know if that's still visible sa video. Ayan. Minus 75. 5100. Okay. So, combine nyo lang yung mga kakaparehas, I, J, K. So, the moment now is equal to, we have 50.067I minus 67.088 J plus 45.059 K. Ang unit of course ay in Newton meter. Okay? So yan you can solve for the resultant nito. So mag-solve ng resultant. Yung moment natin gusto niyo i-solve yung resultant niya. But this is the Cartesian vector form of the moment. So ito yung moment along I, moment along J, moment along K direction. So bawat axis, yun yung direction ng moment niya or components ng moments along each axis. Okay? Those are in Newton meter. Okay. Next example. Okay, next example. A 534 Newton force is applied to a lever shaft assembly as shown in the figure. Determine the scalar component of the moment about point O about line OB. So, gagawin natin, we are going to solve for the moment of this force along this axis line OB. So, i-apply naman natin yung scalar triple product. Okay. So, ito may moment siya about point O, itong force natin about point O. No, ito. And kunin daw natin yung component ng moment ng at point O along line OB. Okay? So i-apply natin yung scalar triple product, no. So equation natin, we have discussed kanina that the moment of a certain force about a certain axis is equal to, kunin muna natin yung moment niya about a certain point. In this case, point O, ano? So, which is equal to the cross product of yung position vector natin from point O to the line of action, to any point along the line of action of F, times yung unit vector. Ganito yata yung symbol sa module ninyo, no? Unit vector along the line or axis, no? Kung saan natin sinosolve yung component ng moment. So in this case, line OB. Okay, so tatlo yung kailangan natin. Position vector, yung vector form ng F, and then the unit vector along the line or axis, no? So isa-isahin muna natin i-identify itong mga ito. So all of these should be expressed in vector form or Cartesian vector form. Let's start with R. So R, ano ulit yung R? So bale, mag-moment muna tayo sa point. So in this case, sinabi doon na mag-moment tayo about point O, and then kunin natin yung component niya component of that moment along OB. Okay, along axis OB. Alright. So, let's solve for the moment at point O muna. Okay. So yung point O natin, ibig sabihin, yung position vector natin, it should be yung position vector. Ito ko lang isulat sa baba para mas malawak. R. So we'll start at point O along the line of any point along the line of action of F. So ano yung line of action ng F? Ito. So dapat ang piliin natin na point ay sa point na alam natin yung coordinates. Para masolve natin yung position vector, no? So, where would that be? Saan yung point na yan? Ito. So, saan yung... So, where is that point? So, let's just choose yung point A. So, 0 ay from point O to point A. So, let's R, O, A. So, kailangan muna nating identify, of course, yung coordinates ng A. So, ano yung coordinates ng A? X coordinate ng A is, X coordinate, that's 275 mm. Okay. So, 275 mm, convert na lang natin sa meters. So, that is 0.275. Y coordinate niya is 350. So, it's 0.35. And then, of course, wala siyang Z, so 0. So, dito naman, ayan, coordinates at the origin. Okay? So, ROA then is equal to, so head minus tail. Ito yun, lagyan ko na lang ng line. Yeah. Okay. So, saan tayo? Disruptions kanina. So, head minus tail. So, kunin natin, ito yung line natin from point O to any point along the line of action of F. So, this is ROA. Okay, so head minus tail, head minus 0. So, that is 0.275I plus 0.350 minus 0 is 0.350. And then, wala J. So, wala siyang K, no, 0. Okay, so, okay na tayo sa ROA. Next is, i-convert naman natin yung F in Cartesian vector form. Okay. Convert natin yung F in Cartesian vector form. So, given yung magnitude ng F, it's 534 newtons. times yung position vector natin ng F. So, we already know the, ito, yung head natin minus tail. So, yung head natin dito, alam natin yung coordinates. Maybe we can also solve for the coordinates of the tail of the force. So, yung coordinates ng tail natin, x coordinate is 325. So, it's 0.325. Y coordinate ay wala, Z coordinate is 400. That is 0.4. So I think we're good. So we have 0.325 minus 0.275. That is equivalent to 0.05, or that's negative ba? Hindi naman. Okay, so yun. So negative pala kasi ito pala yung head natin. So negative 0.275 minus 0.325, that is negative 0.05i. Okay, and then 0.350 minus 0, so that is plus 0.350j, and then minus, so 0.0 minus 0.4, that is minus 0.4k, divided by yung distance between the 2 points, that is equivalent to, ito na, alam na natin yan kung paano i-solve. I'll just write it na. Okay, so yan na. So yung ating Cartesian vector form of F, so you know how to operate, you know how to solve this na, no? That is minus 50.01 for I plus 350.096 J minus 400.109 K. Okay, so ito na yung Cartesian vector form ng ating force F. Next naman is the unit vector. Ito. Unit vector, sabi dito, along OB. Okay. So, ang unit vector natin along OB is equal to yung position vector all over the distance, between the 2 points. So, let's identify muna yung coordinates ng B. So, coordinates ng B, kailangan natin yan para ma-solve yung position vector. So, x coordinate I, x coordinate natin, 0.275. Y coordinate is 0. Z coordinate is 0.15. Alright? So, head minus tail ulit. So, 0.275i, 0 minus 0, so 0 yung j natin, plus 0j, and then plus 0.15 minus 0, so that is 0.15k all over yung distance. So you have 0.275 squared. Okay. And OB natin is the position vector, position vector. 0.878i plus 0.479k. So wala tayong value ng j dyan. Okay? So kompleto na tayo. ROA, F, position vector along the axis. Okay. Now we can now perform yung cross product natin. Sana magkasya itong space. Ayan, okay? So, M, moment of the force along line OB is equal to, take note pala, unit vectors are always less than 1. So, ang arrangement natin, MOB is equal to ROA F OB pala yan. Ayan. Okay. So we have ROA here. So first row natin, 0.275, $350, and then 0, then minus 50.014. Second row yung F, coefficients ng F, 350.096 and minus 400.109. Last naman na row itong ating unit vector along axis OB or line OB. Okay, so we have 0.878, then 0, and then 0.479. So applying the basket method, we are going to copy yung first two columns. Then basket method. Okay. So MOB is equal to, we have 0.275 times 350.096. So i-add lang natin ng product yung mga ito. Okay? Ito, so 0 na yan, no? Ilalagay sa equation para hindi humaba. Minus so obviously ito ay 0. 0 din yan. Ito may value, no? Kita pa ba? Kita pa. So the moment of the force about line OB is equal to, so simplify nyo lang ito, then we will be arriving with this value, negative 68.452 Newton meter. So that would be the answer for this particular problem or example.